All right, let us go ahead and get started for today. Welcome back for another exciting week in the world of databases. Can you, out in internet land, post a message in the chat? Can you see me okay? Can you hear me okay? Great, great. Man, the technology is just awesome when it actually works. All right, well then. Last week we introduced the select command, and it's probably the most useful SQL code in the world. This week we're going to expand on that. Oh, get that looked up. All right. This week we're going to expand on that by retrieving from 2 or more tables. Everything you did last week was just one single table, just to kind of get us started. We looked at the main parts of that select, where you choose which table you want with the from. You choose any criteria with the where. And you specify a sort using the order by. And finally, there's a limit to say how many query results you want. Sometimes you might just want the top 5 or even the top 1. And so you can say limit so that you don't get hundreds of records being returned. So do you have any questions on any of that before we continue? I want to make sure that we have the foundation in place. Do you have any questions on that, or questions about the homework, or anything else before we proceed? All right, well, I will interpret that silence as good. So I will take a look at your homework for this week, and you should have received feedback for the homework from the first week, and try to keep that pace going for the rest of the semester. You've got stuff due Sunday night. I'll grade it the following week, and then we'll move on to the next week. All right. Well then, let's get into it. There's a lot of stuff here. This select thing is really powerful. But the main thing that we want for today is to pay attention to this new term, this new SQL code called join. This is how we're going to bring together multiple tables. There's different types of joins. This example on this slide shows an inner join. There's outer joins, there's left joins, there's right joins, there's cross joins. Lots of different ways to work with multiple tables. And I'll warn you, this does get a little complicated. But also, I think it's a little more difficult, or no, wait, it looks more difficult than it actually is. But it will take some practice. And so if this doesn't all click today, we'll come back on Wednesday and we'll be doing it again next week. And this is kind of a thing that you develop with practice. I could go on and on about computer science and set theory and math and all that. And I think the best way to really learn all of these different joins is with some practice, some experimentation, some trial and error, because some types of joins are very common and some are very, very obscure. And you'll narrow it down to just 2 or 3 common types. That'll satisfy 90% of your database kind of queries. The key to making these joins work is to think back to the first database class where we talk about primary keys. Do you remember that, where you have some kind of identifier that makes each row unique? A lot of times it's just a number. Computers are great for working with numbers. But then there's also the concept of a foreign key, where that primary key shows up in a different table, and that makes what's called a relationship. And so a foreign key in one table matches the primary key in another table, and that's what a join is going to be with this SQL code. We're going to say which keys match in which tables. Another term to remember from the database class is the idea of cardinality. Do you remember that one? And do you use that in everyday conversation? Cardinality is a fancy way of saying how many. And in our relationships, we have one-to-many relationships. We have one-to-one relationships. We have many-to-many relationships and others. And this is where that term cardinality comes in. These joins will require us to understand is something one-to-one, one-to-many, and that sort of thing. All right, I'm going to zip through these slides pretty quickly, but as I said, there's a certain type of thing called an inner join, and let's keep going here. There's a self join where a table has a foreign key and a primary key in the same table. Check this one out. Joins 4 tables. All right, we can see a join for invoices, join for invoice line items, join for general ledger. Don't worry about the details here right now. I just want to introduce the idea that this join mechanism can be very powerful. But look at this. You end up writing just an enormous amount of code to make this work. And once you've done this for a while, this actually, believe it or not, will make sense. Maybe not today, but it's really powerful. That's the point. All right, and then we can have outer joins. There's 2 types of outer joins, left, and I'm just drawing terribly here because I'm so careless, or maybe I've had too much coffee already. There's left joins and right joins. Technically, it's a left outer join and a right outer join. Nobody actually says outer join because we're lazy. Great. Here's a combination of an outer and inner join. And, all right. Using, yeah, great. Natural join, cross join. All right. And unions, we're not going to get really into unions. All right, and that's the entire slide deck for chapter 4 in the book. It is a lot of stuff, and it is complicated, but it's also not once you get the hang of it. And so I don't want to just click through a bunch of slides and read them to you. I think it's a whole lot better to actually do some stuff. So let's do some stuff. And the way I want to do some of these things is in the eLearn system. under week 3 in the lesson. Topic 3, and then in the lesson, there's this link here for something called lecture notes. And I'm going to do some of these as we go through this morning. I am the type of professor here. I don't like to follow a script. I like to make it up as I go. So I will probably deviate from this or find some interesting tangents to go on. But this is good practice, and I'll also paste some of these commands in the chat, but after we're done today, you might run through these exercises here a little more thoroughly, just to get some experience, because as I said, I think it's the practice that makes this clearer, not watching a bunch of PowerPoint slides. So I'll give you a minute to bring that up, and I'll also take a minute to get myself set up. Can you classroom people read that? It's the same settings as last week. Font settings, I think that's okay. I don't know. I can record a bit. There it goes. Yeah, okay, yeah, it's just a control and scroll wheel. Ah, computers. All right. All right, everybody got that? We're ready to continue. First thing to talk about, we mentioned this very briefly last week, and this will become more important this week, working with multiple tables. And that's the idea of an alias. So if I write a real simple select like this, go ahead and run it, the computer gives me an answer of 2. Great, we can perform addition, how exciting. But then notice the column heading here, 1 plus 1. The computer, the database uses that expression as a column name, and that's maybe not always clear. So there is this SQL keyword as, where you can provide what's called an alias. So if I call this sum and run it again, I get the same result down below here, but notice the column, the column heading says sum. So we're going to be using aliases a lot here because it's going to be easier to type alias names than full table names. When we bring 3 or 4 tables together, and they've got long names like invoice underscore lines, general underscore ledger, we'll be using those aliases to save us some time. We'll see that in just a minute. Excuse me. Another part of select that I want to remind you about that'll be helpful for this week also is that we can specify fully qualified table names. You've been using that use command, USE, to say which database you want to work with. You can also avoid that by specifying this fully qualified name, which is the name of the database or the schema, in this case, animals, that corresponds to this name here in my schema browser. And then in that database, I have a table called pets. And so when I run this, I get those pets we were playing with earlier. And I don't have to mess around with that use command. This may or may not be as helpful, but I do want to throw it out there because you're going to be doing a lot of selects as part of this class, so the more you know, the better. All right, let's take a look from that lecture notes document. The first example here on the first page is, it says Cartesian join. Just going to paste this in the chat. This doesn't help you classroom folks, sorry, but you can copy and paste from that document. We'll create another database here called practice 2. And then later on, insert some values. So we're creating 2 really simple tables. One's called snacks, and one's called drinks. Error. What the heck? Paste. Why does this look so terrible? Database exists. All right, fine, don't create it again. Error in my syntax. What the heck? This is so simple, but what am I missing?
Did you refresh your schema?
Yeah. Yeah, it's there, but because I already have a practice 2 database, let me just delete that and try it again. You need 2 dashes and a space to form a comment. I'm going to create it again now, so it's uncommented. All right. It's working now. All right, well, thanks everybody for that. That was supposed to be simple. And then let's do the inserts. I don't know why this query window is so small. Oh my gosh, this is supposed to be simple. All right, I think I got this here. So here's a first select. Select star means select everything from, and then we say the name of the table, or in this case, the name of the tables, plural, each table name separated by a comma. All right, and it looks like I ran my insert twice because I've got two entries for OJ and milk. It doesn't matter. This is all just to kind of demonstrate the principle here. And this is the first kind of join, called a Cartesian join. Sometimes it's called a cross join. And this gives every combination of drink and snack.
Oh, is that why it gave me Coke like 4 times?
Exactly. You get Coke 4 times, each time with chips, cookies, carrots, cheese, and chips, and then repeat for milk, cookies, carrots, cheese, chips, and then repeat for coffee, and so on. So every combination of values from both of those tables. And it's not very useful, actually, but it's a good introduction here. It's real simple syntax. Just specify as many tables as you want, each one separated by a comma. I'll try to repair my mess. Here's a new SQL command, delete. What do you think that does? All right, where's my inserts again? One, wait, one, all right. All right. As I said, not very useful, but it's a good starting point. So let's do some more. This is on page 3. We're going to set tables for cars, accessories, and accessory manufacturer. So let's paste that into the chat or copy from this isn't copy pasting correctly. What the heck? Copy.
Yeah, that first line is missing an I in insert.
Yeah, it's like my paste. There we go. That shouldn't have been so difficult, but thanks. Paste. Get rid of these comments here so that we can let's put that use command in front so we can just throw all of this into this practice database. just delete that, try again. Man, I am just having a difficult time. Okay, great. All right, so we have cars. So I can say select star from cars just to kind of see what's what. So different cars, and then there's also accessories. And then there's also accessory manufacturer. And we can see who manufactures what accessories for what cars. All right. So let's go back to the let's go back to the accessories table. Then we can see that there is this car model column, and then an accessory manufacturer column that says which accessory goes with which car, with which accessory manufacturer. These are the keys that join the tables together. So let's take a look at this query. Let's only look at accessories for a Civic. So let's put a where on here. And this gives me these three accessories that are available for a Civic. And let's bring in the car information. All I have is the model. I don't have the manufacturer here because that's in another table. So this will be another example of a join where we want to bring the information in from the cars table to see that information. So let's add a join to our select. And then we say on, and this is where we tell the database, how do we connect these two tables together? And so the way we join is with that fully qualified table name. What's it called? In cars, it's called car manoff. No, car model. Yeah. And so this tells the computer how to, or the database at least, how to connect them together. Notice the fully qualified name, that accessories dot and cars dot, because both tables have a column named car model. We have to tell the computer which one is which. So go to the accessories table grab its car model and find everything where it's equal to the cars table with its cars model. And if I run this, I'm probably going to get an error, and that's here, because the computer doesn't know, well, which car model table do you mean? In this case, they're both the same, so it doesn't really matter. But I do have to spell it out to satisfy the database system. Oh, computer's so needy. So when we do that, we have this new column here that shows the car manufacturer and that manufacturer ID number. They're all 5s. So just like this, we've brought information in from 2 tables. So we see what the accessory is on the left-hand side and the name of the car manufacturer on the right-hand side. If I scroll off to the right, I can see the rest of that column.
So when you use the on syntax, does it only connect the primary keys and like only joins that value, or does it join the entire table together?
Well, it joins on those keys, on those 2 keys, but then brings in all the tables, or all the columns from both tables. So all the columns from my from clause, plus all the columns from my join clause.
Okay.
I think that's what you're asking?
Yeah.
All right. All right. Let's talk about aliases some more, because if you look at the code I have here, I spelled out the word accessories, accessories, accessories. It's a lot of typing, and so let's make an alias for that. Normally, when you're working with computer systems, whether it's databases or computer programming, you want to give things good descriptive names. Right, your variables in your computer program, your field names in your database should describe what they are. With the aliases, I am lazy, and I encourage you to be lazy as well. And so if we use an alias here as just A, and another alias here, C, we can rewrite this without such a long, fully qualified name. And as long as you're clear on what A means and what C means, I think this is actually a lot easier to understand than those big, long, fully qualified table names.
What's C?
What's that?
What's C for?
Short for cars. Right? C is short for cars, so I don't have to spell it out. And then A is short for accessories, so I don't have to spell it out.
Got a question.
Yeah.
So when you're doing that alias and the actual programming where you're doing the accessories dot cars for models, could you still have accessories and would it work, or do you have to name it as hey?
All right. So I don't know if you can hear that out there. So the question is, once you use an alias, do you have to always use that alias for the rest? No. You can mix aliases and the full name however you want. And why am I getting an error all of a sudden? Oh, I fixed that. Let me get rid of the word as and see if that's what it's complaining about, and then we'll see. And now it's working. Okay. You use, apparently, as for column aliases, but not table aliases. This is where we have different dialects of this SQL language. Different products, different systems have varying syntax. So you don't use the as. You just say the full table name space and then the alias.
I typed as and it worked for me.
Really? Okay.
No, but it wouldn't run if I had at where the C, if I had cars.car model equals civic, it wouldn't run. But when I use the alias, it would.
All right, well,
Yeah, it was
Nick,
like that for me too.
all right, well, so Nick, there's your answer. You have to use the aliases. All right, well, thanks for that, Brandon, Cooper.
Well, in the book, when it talks about aliases on page 117, it does not have you code the as keyword.
All right, thanks. Yeah, and most, oh, okay, thanks, John. All right, I guess you do have to use it. And yes, thanks, Heather. Most computer programmer types are really lazy, and so you don't always see that as. If you're going to be lazy and abbreviate with one-letter aliases, you might as well be full-on lazy and get rid of the as well. All right, let's add a third table. We have the accessory manufacturers. We see here roof rack accessory. And we can see the manufacturer is ABC, or in this case, the spoiler is made by the worst. Let's go ahead and pull in information about that accessory, or the accessory manufacturer. And so it's a matter of adding another join. I'm going to call that M for manufacturer, just to be lazy with my aliases. And then same deal, I have the keyword on to tell the database how to connect these tables together. So we just make sure I got my field names correct. All right, Akmanov. All right, fingers crossed. Let's see if this one works. All right. All right, so now we get 3 tables worth of field names here, all these different columns. And this is the principle that you'll be using for all of these different kinds of joins, where you join in another table, and then you tell the computer what's the relationship, how are they connected, which key in this table matches up with which key in the other table.
If you were to put the like statement, or yeah, the like syntax, where would it go? Would it go after where? Does it go like after the equal sign?
Well, so the question is about like. You don't really use likes on joins. The joins have to be an exact match. This record in this table corresponds to this record in that table. So the only place you can use a like is in a where clause. Right, so every car that has an I in its name. So the join conditions have to be exact. The likes are only in the where clause. All right, after all that hard work, I'm going to delete it. Let's do that again with some simpler syntax, what MySQL calls a natural join. This is the top of page 5 if you're following along. And my screen sharing just got that here. Let's try this again. It's a slightly different syntax. Notice in the select, we're only grabbing certain fields. We don't want everything in this example. And we're going to select from the cars table and then natural join on the accessories. And in this case, the MySQL database engine figures out that both tables, the cars table and the accessories table, have a field name in common. So since they both share the same field name, MySQL can sort of infer that they should be joined together. And here we get a list of car models and the accessories that go with them. This is a much simpler syntax and probably much easier to understand, but it does require that your primary key has the same name as the foreign key, and it doesn't work in all database systems. This is a dialect for MySQL, but since we're using that in this class, you're welcome to use these kind of features, but not all database systems might have them. Here's another example from the top of page 5. Yet another. Why does copy not work? Copy, paste. And in this example, we have this keyword using. And the name of the field in parentheses that's common to both tables. This is a little more explicit, but by using that same car model field in both tables, we get yet another way to bring these tables together. All right, I'll be saying this a lot as we go through this entire semester in this class. There's a lot of parallels between database development and this SQL code and computer programming if you're doing C++ or Java or Python or whatever. And I'm going to say that right now. There are multiple ways to accomplish a task with this SQL code, just like in programming. Should I do it with a for loop or should I do it with a while loop? Well, both ways could work. Maybe one way is clearer, maybe one way is faster. There's not always a right answer. And I've shown you a couple here, different ways to accomplish a task. And when I'm doing the homework, grading your homework, when you're doing the homework, just remember that I'm not necessarily looking for exactly correct answers. As long as you get the right results the right way, the exact syntax that you use doesn't always matter. Let me modify this query a little bit. And you can use the same select options that we talked about last week with these joins when you're working with multiple tables. So I can add an order by here. And now I can see A4 at the top of the list, and then C's and F's. I can add wheres. You can see there's this column for inventory. You can see this bike rack has an inventory of 0. So maybe I only want items that are in stock, so I can add a where and just show me everything that's in stock, where the inventory is greater than 0. All right, and this, I think, starts to show where this select thing can get to be so powerful. You've got all these options, and you can write some large queries to get what you want. There were some monsters in those slides as I clicked through them earlier today. All right. All right, how's it going so far? Success or questions? All right, thanks, James. Good, all right. All right. Let's go ahead and pause here, and let me push the right buttons. This may be difficult to read, but it's in that lecture notes. You remember Venn diagrams where you have, a set here and a set here, and then there's the overlap. That's what's being shown in this picture, where there's lots and lots of different ways to do these joins. We've got the table A and the table B, and do we want the common ones or the exclusion of them here? And this is where it looks harder than it is, but also this is where it becomes very powerful. There's lots and lots of different ways to get at the values that you want out of your database. Do not memorize this, all right? It's just kind of there to show you that you do have that power and flexibility. But it's really the one-to-many kind of joins that are the most common. And so that's going to be the left join here. I did say earlier that this will get better with practice, and if it's not quite clicking right now, that's okay. But you will make some larger and larger select queries as we go through this class. All right. Let me, yeah, okay, all right. There's a lot more in this chapter in the book, and we have an entire class session on Wednesday. I do think this is enough to get us started, and so I'd like to pause here and take a look at the homework for this week. And before we actually look at the homework, let's take a look at this diagram. This is in the eLearn system when you download the homework assignment. This is available as a separate download. This is an entity relationship diagram where each rectangular area is an entity which corresponds to a table in the database and gives you a nice overview of what you'll be working with. You can't just jump right in and start typing a bunch of select statements. You need to take a few minutes and understand what's going on. And this looks a little crazy at first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tables in here. But if you study it for a minute, you can start to see some of the relationships and how they may or may not make sense. So, for example, I have warehouses as an entity. That's where I store my stuff. And the warehouse has a location. And that location is within a country. And that country is within a region. And you can see by the little arrows here, you may not be able to see on my screen, but they've got those little cardinality indicators, where these are one-to-many relationship. A warehouse is in one location, but one location may have many warehouses. A location is in a country, but a country may have many locations, and a region may have many countries. And the same with the other items in here. We have orders, and the order is placed by a customer, and the order is composed of order items. All right, I want 5 of these, and 10 of these, and 30 of these. And so this represents a lot of what you might see in a boring old business database. The homework instructions and the database script refers to it as the Oracle database. Oracle is another manufacturer of database software. Oracle is the name of the company, and Oracle is also the name of the database product itself. Oracle is huge in the business world, even though you may never have heard of them. The only reason it's called the Oracle database is that this is a sample that we downloaded from the Oracle company. They said, here's a little database for the world to play with. So we said, okay, look, we'll use that. So it was just sort of credit to Oracle for writing this up and providing it, but it's got nothing to do really with the company Oracle or the database product Oracle. It's just a little playground for us to join multiple tables. Oh my gosh, we have so many tables to join and play with. So do take a little time to study that, because you'll need to know it to answer the homework questions. All right, and then also in the eLearn system is the actual homework instructions. There are 2 database scripts to download from the eLearn system to make this work. The first one is the build script, which will create the tables, set up the tables, the field names, and all of that. And then the other does what we call populate. Populate is a technical term that we use to mean to put data in. So this will have a bunch of insert statements to put all the different records into the database or into the database tables so that you actually can have some data to work with. So you'll have to download those, and for some reason it's in a Microsoft Word document, so you can download that, copy the text from Microsoft Word, and paste it into your MySQL workbench. And then it's the same kind of deal as before. You have a task on the left-hand side and some sample output here on the right-hand side with my yellow highlights to be my high-tech anti-forgery system. This gives you an idea of what I'm looking for, and give me a screenshot of what you came up with, and be sure to include the select statement that you used to get those results. And whether you try to paste it into this right-hand cell, or make a new table row underneath, or maybe start up an entirely new Microsoft Word document, just start with question 3 and paste your screenshots in there. However you want to do that is fine with me. All right. Let's just take a look at this number 4 here. Display the product name, warehouse name, and category of each product. How am I going to do that? Well, if I look back at my database diagram, I can see product name is probably going to be in the products table, and warehouse name is listed over here, and category, there's a separate product category over here. For this query, whoops, let me zoom in a little bit here. You'll notice that there is this inventories table in between. And if you look at the little crow's feet here, this is a many-to-many relationship. This is how we specify that a product, one product could be in multiple warehouses, and one warehouse could have multiple products. So that might be a little tricky one to get to, but ultimately it's a bunch of joins. You join the different tables together to get the results that you're looking for. All right, and it just keeps going and going up until question number 11.
The worksheet from the eLearn is a little bit different. There's like goes to question 12, and the format's a tad different, like the prompts for answering the questions and such. Is that okay?
I thought I downloaded, thought I downloaded a fresh copy from the system. What content? Topic 3, is this? So the question was that homework document that I had on the screen is different from it's been updated since last time. You're right, thank you. Let me download a fresh copy here. All right, I don't know if you all heard that. I was bringing up an older version of the homework document. And so that's slightly, there's been some changes since last time, but the point remains the same. We're joining in multiple tables, write the queries to answer the question, and give me the screenshots. Thank you. All right. So let's go back to this syntax diagram from the very beginning. We can start to see the kinds of things that we looked at today. Where we select from a table, and then we join another table, and then we specify this join condition. How do the two tables relate to each other. And you can specify as many of these joins as you need to bring in as many tables as you want. Okay, well, I think that's a good stopping point, even if it's not all entirely clear. This can be complicated. Are there any final questions here before we wrap? All right, well then, let me apologize for the rough start this morning. It's a cloudy, sleepy Monday. Hopefully Wednesday will go a little more smoothly. Take a look at this chapter 4 in the book, and we'll do it again on Wednesday. Have a good day, and see you.